And we're so excited to welcome you to the official kickoff for our very first machine learning focused hackathon. And this hackathon is co-sponsored with Weights and Biases. Thanks so much for being here with us today. I'm Ornella from the community team, and I have some awesome guests from Weights and Biases with me today. So I will let them introduce themselves.
Brilliant. Thanks a million, Ornella. So hey, everyone. Super excited to be hacking with you the next week. I'm Morgan. I work on the growth ML team in Weights and Biases. So I've been in Weights and Biases about 2 years as a machine learning engineer and then managing a team here. And yeah, have had a lot of fun in the past few weeks working with Ornella and the team at Replit. And yeah, looking forward to seeing some cool projects by this time next week. And let me hand it over to Corey.
Hey everyone, my name is Corey. I've only been working at Weights and Biases for about a month now, but I'm the community manager there. So I know you guys have a fantastic community at Replit, and we have a fantastic community at Weights and Biases. So really happy to kind of be able to join forces here for this first ML hackathon, and also really appreciate you for joining us on a Saturday. I know that's never easy to do. So we're happy to help support you and look forward to all the great things that you create.
Amazing. We're so happy to have Morgan and Corey here with us. So I wanted to walk through some logistics first, just for the hackathon kickoff. And I first wanted to say that if today is your first time hearing about the hackathon, don't worry, it's not too late to sign up. So the waitlist application form on the hackathon website will be open until Wednesday. We'll be accepting new people every day and granting cycles for GPU access every day. So it's really not too late to sign up, and you still have time to build out an awesome project as long as you sign up by Wednesday. We also just opened up the Machine Learning Hackathon channel on our Discord. So we'll put the link in the chat, and starting on Monday morning, we'll have machine learning engineers from Weights and Biases helping people out with their project and providing support. We'll also have a live Replit 101 this week with David Morgan, so you can pop in live and ask questions during his live office hour. That'll be awesome. So we'll post all the support links in the chat as well. And really the most important thing for this hackathon is that you have to use both Weights and Biases and Replit in your project. And when you get the acceptance email into the hackathon, you'll get a bunch of resources for how to do that. So if it's your first time using Weights and Biases, or if it's your first time using Replit, don't worry, we have you covered on both fronts. And just for prize eligibility, I wanted to mention that the grand prize and honorable mention, all projects that use Replit and Weights and Biases will be eligible for both, but you'll have to choose whether you're submitting a REPL or a Weights and Biases report, and then you'll be eligible for either Best REPL or Best Weights and Biases report. And that'll all be clear on the submission form, which I'll talk about at the end of this session. So the bulk of the session today, Morgan's going to run us through an awesome example of using Replit and Weights and Biases together. This is going to be a quick start for anyone who, is just wondering where to get started for the hackathon. So I'll take Corey and myself off the screen, and we'll let Morgan take it away.
Perfect. Thanks, Anela. Okay, let me share my screen here. And there we go. Okay. So yeah, Weights and Biases and Replit. So I'll give for the Replit folks on the call, give folks a quick idea of what Weights and Biases is and how it's useful in the machine learning world, and then take a quick tour through a few REPLs we've put together to get people started, and to show how kind of Weights and Biases fits into the picture when things come to ML. And so what we're looking at here is Weights and Biases workspace. Before I get into that, I can give a little context around why a tool like Weights and Biases is useful when it comes to machine learning. And so unlike kind of traditional software engineering, machine learning can be much more experimental. You're running a lot of like different trials, you're trying a lot of different like parameters, And so there's a lot more, accumulation of like artifacts and learnings and notes of like all the things you've done to try and, get the best out of your model. And so having one place to store all of those results is pretty important. And again, for example, in machine learning, another difference between software engineering is you can actually have a machine learning model that looks like it's working well and giving, reasonable predictions and has reasonable like accuracy metrics. But you might actually like have a bug in that in there. So compared to like software where, if you have a bug in your program, it's going to like fail or it's going to be like very obvious. In machine learning, you can have these like little silent bugs, and so they can be like kind of tricky and like gnarly to track down. And so again, with like tools like weights and biases, you're able to look back over all of the settings of your experiment, and maybe you forgot to set something on or off, or you some value was set at like 10 times higher than it should have been, that doesn't cause the model to fail, but causes it to perform worse than it would have. So being able to like go back and like track down those like issues is crucial to like getting the most out of your machine learning, and especially when you're running a lot of experiments on a lot of GPUs. It can save you a lot of time and sometimes a lot of money too. But let me give a quick tour of weights and biases and how it's going to be useful to folks this week. And so what we're looking at here is the workspace for weights and biases. And see here on the left of the screen, we have all of our experiments, and you can see down here, I'll give it a bit of a zoom, and we have about 100 experiments in this workspace. And we're not going to look through all of these experiments, but here we can kind of see an aggregation of kind of like what are some of the top performing experiments that we have. And so, some of these like top panels just give us like the scores for some of the experiments that work the best. And so, for example, here let's try this one. For example, so this is our accuracy score, and we can see this experiment, which has this lovely name, Rosy Sweep, and these are random names that weights and biases gives your experiments. We can actually click into Rosy Sweep and see how in more detail how this experiment ran. And so again, we have like the results that we have there. We also have a lot of system metrics in terms of your disk utilization, CPU utilization. If you're using a GPU, you can also see your GPU use here. And so the nice thing with weights and biases is that it keeps track of a lot of this information automatically. And so, for example, if you're running this within a Git folder, it'll also take note of the state of that Git repository at that time. So you'll be able to like roll back that repository and like run the exact same experiment if you ever need to. We've also here, logged a huge amount of information about like the settings that we used both in our model and in our training pipeline. So again, if we need to like replicate this, if this is the magic model and the magic experiment that has the best run, we can go back and replicate exactly that before we go and deploy it in a cool little Replit. Another handy feature that's off by default, but you can turn it on, is the code saving. And so again, if you run weights and biases and you turn this on in your user settings, it'll also take a snapshot of the script or the notebook or the REPL that you're running weights and biases in. So again, in terms of being able to like understand exactly what code you used to get the result, it's all here for you in weights and biases. And so that's for a single experiment. But often, we like you saw earlier, like we're running tens or 100 experiments, and so we want to understand exactly what are the main or the most important settings or like hyperparameters, as they're known in machine learning, to get the most out of your model. And so here, we have charts like this, which is called a parallel coordinates plot. And in this case, it looks a bit gnarly. You can't really like glean too many insights from this. So here we're looking at 4 different hyperparameters or different training settings. and different values for each. And then on the last column over here, we have the metric that we care about. In this case, the metric is called AUC, and a higher AUC is better. And so we want to understand, okay, for all of these different experiments with all these different settings, which resulted in the highest AUC. And so here we can just click and drag in this workspace and filter. And now we have a much clearer idea of what are the, some of the better settings that we should consider when training our models. And so you can see, for example, like some settings, say in this column here, which is the learning rate, which is kind of like, think of it as like how quickly the model updates itself after each sample of data that it sees, while it's training. And so here you can see this model and this pipeline is fairly sensitive to learning rates, between 0.8 and 0.85 here. Whereas, other hyperparameters, maybe it's not so sensitive. We have like anything from this hyperparameter, which is like mean child weight. And this is, anywhere from like 120 down to 20. And again, gamma somewhere in the middle is like 0.5 to 0.7, like looks like a promising range. And again, for like early stopping rounds, doesn't look to be so sensitive. We kind of have like decent results across a wide range of early stopping rounds. And so with charts like this, you can, after running a large amount of experiments, or even, 5 or 10, you can, develop a bit of like an intuition of what are the ranges that your models tend to perform well in. And that's quite important when training, especially in machine learning. Some of it is almost can be at times more of an art than a science. And so doing a lot of experimentation and understanding how your model responds to different settings, helps you build up an intuition of kind of how to get the best out of your models. And so these are some of the panels that we get in weights and biases. To create any one of these panels, you can just click on these add panel buttons, and so we can replicate that chart, the parallel coordinates chart again, for example. And so here we have all the options that we have, and so we can like click on that. And so we need to add our columns, and so we'll start with the metric that we care about. And in this case, we can go for accuracy, and we'll do this one. Yep. And now we're going to add the hyperparameters that we're interested in. And so we can do like learning rate again. And we can do one more. Let's go with the max, I think it's max child, right? No, in child rate, yes. Let's try that one. Just take a second to load up. And okay, and it looks like this accuracy metric actually wasn't populating. So let's swap that out for another one. No, let's go with AUC score. We'll keep it simple, right? This one. Great, and we can get rid of this accuracy. Cool, and that's it. There you can click OK. We can click and drag this. And now we've recreated this parallel coordinates plot. And so creating plots like this in your workspace is like super straightforward, really, really easy to do. You'll also notice when I filtered the plot down here, it's actually filtered across my entire workspace. And so if you keep an eye on these little eyelids on the left for each of our experiments, when I close that, it actually, displays every run, not only in this chart, but across all of the other charts in our workspace. So it's also a useful way to filter your entire workspace by filtering like single charts. The other useful thing I wanted to show was our run comparison chart. And so we can again click on add panel. And so again, when you're running a lot of experiments, it can be difficult to keep track of all of the changes you are making between them. So for example, here you see for our configs, there's a lot to keep track of here, and then like a whole bunch of runs to keep an eye on. But if we toggle this little diff only switch here, we can filter this down to only the settings that have changed between each one. And so we only care about, say, the configs that we've changed. And so now you can see, okay, exactly for each one of these runs, what were the different settings that we picked for them. And again, that can be useful, especially if you have it narrowed it down to maybe only, if we hide all of these and you've only narrowed it down to like 3 or 4, candidate runs, then you can like zoom in and say, okay, like what are the most interesting, or what were the differences between all of these runs here, and get a like more fine-grained idea of an understanding of how this model trains. Super. And so once you have finished, or you have identified, some interesting results, you might want to keep a note of those results, either for yourself in terms of like a little kind of training journal, or as a more polished piece of analysis that you might want to share with a friend, or a supervisor, or a manager. And so for those bits of work, we have a tool called Reports, and here we can see some of our favorite Weights and Biases reports. And reports are basically like word editors with weights and biases charts built into it. So you get the advantage of all of the like functionality that you would expect from a word editor, but with the addition of interactive weights and biases charts. And so we can see a few in this example report here that kind of shows a quick outline of all of the different features. And so this is obviously a little exaggerated, but if you didn't have embedded weights and biases charts, you might be sharing something like this, which are like screenshots, and like maybe like low fidelity screenshots like dropped into like a Slack or a Discord, or like a passed around in emails. But the alternative is that you can embed these like rich weights and biases plots, and anyone visiting these plots can kind of take a look at them, zoom in if they're like interested in a particular run. They can like click into that run and using weights and biases reports. And so like we saw in our workspace, any chart you can have in your workspace, you can also like have in your report. Here below, we can see all of the runs in this experiment, and we can, if we I think we can open some of those. I know this particular one is locked. And then the other nice feature that we have as like a visualization tool are weights and biases tables. And so here it's for those of you familiar with like data frames, you can think of it like as a data frame, but where you can also visualize rich media. So that could be images, that could be video, that could be audio. We also have HTML, point clouds, like a huge range of like media formats. And so here you can do a little bit more exploration of like how your model is training, or even just like see what your predictions look like. And so in this case, this is the data set called Fashion MNIST, where the idea is to predict, the model has to learn, what class of, what type of clothes is in the image. And so here in this column, you can see these are the predictions from the model. And then here is the ground truth. So with tables, you can get all of the like basic functionality you'd expect in a table, like being able to like sort columns, but you can also do some interesting actions like grouping the ground truth. Now we will see for every class of clothing, starting with dresses here, for example, you can explore all of the different samples that were in our evaluation data set, and you can browse through and see, well, is everything like labeled correctly? Are there like maybe borderline cases, for example, here where the model might think could also be like a t-shirt as opposed to like a dress, and kind of understand a little bit more how your model is doing. And so when you group by one column, all of the other columns get grouped too. And so we can then see in these columns here, this is the distribution of the scores for each one of the categories that our model is giving. And so the higher the score, the more likely it's going to predict that category. So here for the dress category, as you'd expect in a good model, most of the predictions are on the higher end, somewhere between 0.9 and 1. And so it's like predicting correctly that it's a dress. And, for like to contrast that, we can see, okay, like pullover is for the ground truth of a pullover, predictions of dress are close to 0 there. And so that's like one useful way to explore your models. We can also verify, was my theory that the model might be confused between dresses and shirts, possibly correct? And we can see here, probably not. Most of the when it comes to like the shirt class, for samples like this, most of the predictions were close to 0. And so our model is doing a good job, differentiating between what is a dress and what is a shirt. And so that's one useful way to use tables. And I'll come back to one or two other like interesting use cases that I think will be helpful for this hackathon in a minute. And so in reports, as well as being able to embed all of our charts, it has all of the expected formatting that you would have in any kind of modern Word editor. And so you have code blocks, LaTeX, checklists, obviously supporting GIFs is crucial, YouTube embeds, linking to other reports, weights and biases reports shows up nicely like this. And it's not here, but we also support like Spotify embeds, SoundCloud embeds, and Twitter embeds. So there's a whole bunch of content you can put into a report to like really tell a nice, like engaging story about your work. And so one useful case for tables is actually exploring your predictions when it comes to playing around with some text to image models. For example, if you're using stable diffusion, like maybe you want to call the API during this hack and do some like interesting like image generation as part of your project. And so it's really important when you're training or fine-tuning or even just like predicting with these models to like be able to keep track of like how your prompts are changing to understand how to get the most out of your model. And so here there's an example of what you might do for a training journal where for over like a few days over the Christmas break, I was just like doing some different experiments, taking quick notes of what the results were and just like dumping them all into a report like this, which was like really handy in retrospect to be able to look back and see what worked and what didn't work here. And so here, for example, is just a table. And so this task that I was trying to do was to fine-tune a stable diffusion model on tortas. And so a torta, if you don't know, is a delicious type of Mexico sandwich. I was in Mexico for Christmas, so this was top of mind. And so here are the here's my training data set. And so examples of tortas that I just pulled off some Google reviews and wanted to visualize to make sure that they all kind of looked okay. And so there's like a nice diversity of shapes and sizes of tortas here. And so we're looking good from like the data set point of view. And then so to log to a table, I don't want to spend too much time looking at code, but we'll go quickly just through this one a little bit. To log to a table, you first call 1db.init. And so to start any weights and biases experiment, this is your the first port of call. Well, obviously after importing our library 1db. And so once you have imported the library, you call 1db.init, and this starts a weights and biases run. And so once you have started that run, you can log anything to it, be it your images or data sets or model files or metrics like we saw earlier. And so in this case, we're going to log a table to this run. And so once we've set it up, passing our weights and biases username to the entity and giving our project a name, and optionally passing in some of the like config values that we care about, we create a table. And so this is how you first instantiate a table, and we give the column names. The column in this case are the concept, which in this particular example is our tortas. We give it the prompt and so this is what we're asking Stable Diffusion to create, and then this is a guidance scale. This is a setting on how much or little the model should pay attention to your prompt. And so once we have that all set up, essentially we're looping through a whole bunch of guidance scales here to understand the impact of different guidance scales. We're generating 5 images, I think, for each one of those settings. And then we're adding that data to a table row by row. So and so that's how you append data to a table, row by row by row. And so we have the name, the prompt, the guidance scale, and then we log all of our images here. And we actually, I was wrong, we have 6 images. And so this is a image tensor here, and we just wrap it in 1db.image to be able to, for weights and biases, to be able to visualize it correctly. And so we do that for each one of the guidance scales that we have. And then when we're ready with our table, we just call 1db.log, and we pass it a dictionary, which in this case is a dictionary of the name of our table and the table object itself. And so 1db.log is what you use to log anything to weights and biases, be it a table, be it your metrics, or be it data sets or model files. And then finally, we call weights and biases, or 1db.finish to finish our weights and biases run. And so we can quickly see the result of logging to a table like this. And so this is like an early version, where I was more exploring just the different guidance scales while keeping the same prompt. And so here you can see our guidance scales, running from 7 to 12. And as these images come back to me, you can kind of get a feel of like if this guidance scale is having like a massive impact on the generated outputs. And this, is TBD. It's not entirely clear that guidance scale in this particular example is making a huge amount of difference, which is a good learning in itself. And so later we tried to explore like, okay, different prompts with the same fixed guidance scale. We set it at 9 in this case. We say, okay, guidance scale at 9 seemed reasonable. Let's see how it goes with a few different examples. And so in this case, in case you can't read, we have a photo of lots of tortas in a green field, looking pretty good. A sketch drawing of a torta floating through space, again, looking pretty good. A torta being eaten by a sheep by Claude Monet, not great here. And so there's probably, something we can do to like, with this prompt to try and make it, more specific or more descriptive and try again. And so being able to keep track of like all of these learnings as you go is with a tool like weights and biases tables is like super useful. And so I've got a whole bunch of tables here. This is going to be linked in one of the docs we're going to share, and yeah, you feel free to browse in your own time. The last thing, and so this is a doc that we're going to share to everyone participating. And this is just a few basics here in terms of what is weights and biases, a link to our quick start guide and like how to sign up for a free account. And I should say weights and biases is completely free for personal use, so you can just feel free to sign up. The one thing you need to do when you start a weights and biases run, you'll be asked for your API key, and so you'll find it at this link here. The prompt in the code will also like give you this link as well every time, so you don't have to note this today. And then you go to this link, you pass it your API key, and then you can log to weights and biases as normal. We recommend for this hack, and when using weights and biases with Replit, it's a good idea to save your one API key to your Replit secrets, and so that way you can just save it there once, and then that'll be available to your REPL in the environment, and you won't have to think about logging this again. As an alternative, but be careful when you're sharing public replits. You could also specifically add it to your script, setting the environment variable in Python here by passing your API key like that. But again, highly recommend you use Replit secrets for your weights and biases API key and any of the API keys you might be using during the hackathon, such as GPT-3 or Stable Diffusion API keys. So here, like I said, we have a bunch of examples of reports for yourselves, as well as a link to the report I just showed you. I wanted to mention one thing. And so when it comes to GPUs on Replit, and so Replit currently have K80s available, which is a GPU from NVIDIA. And so I've had fun playing around with these the last few weeks, and kind of wanted to point out a few things to people when they're using them. And so right now, disk storage on Replit is limited to 1 GB. And so it's worth keeping an eye on your disk usage and maybe considering deleting any like model files or data sets that you're not using. It's also worth considering before downloading a data or a model, or for example, like a large pre-trained model, checking actually the file size there, because you don't want to download a model so big that you won't be able to run it. So again, worth bearing in mind there. And the other thing is just to keep an eye on the memory usage of your GPU. And so you can like easily see that just by running NVIDIA SMI in your shell, and you'll get all of the stats from your GPU there. And at times, it might be worth clearing your GPU cache to be able to free up some memory to do more training. Weights and biases in the system metrics, like I mentioned, also keeps track of your GPU utilization. So on the flip side, you want to make sure that you're using as much of your GPU as you can. And so in weights and biases, it gives you a percent from like 0 to 100% of how much of your GPU memory you're using. And you want to get that up 80, 90, 95% to make sure you're training as fast as possible. What else in this doc? Finally, in this doc, there's a bunch of links to a bunch of resources here, our docs, the community Discord, and a few other Replit examples. And we'll be adding a few more links to this doc as we go during the week. Great. Okay. How are we doing on time? A few more minutes, I think. Cool. So wanted to just point out some of the repls that are on the weights and biases Replit page. And so when you go to replit.com/@wandb, you'll be able to see all of our pinned repls, including this one. And so this is our quick start, and this is just the basics of logging with weights and biases, and we can take a look into the code here. And so one thing you need to do when you're using weights and biases with Replit, because it's a newer environment for us, you need to call this or set this environment variable, 1b console. You set it to wrap, and then you're good to go to do your weights and biases login. And so once you've installed your library and you've imported 1b, you, like I mentioned before, you call 1db.init to start a run. And so this is where you, like as you saw before, you can pass your entity. In this case, I haven't passed the entity because it defaults to your personal user. And you can set your project name. You can set the name of your run. So if you don't love the random names that weights and biases is giving your runs, or you want to put some hint in the name of what you're doing in this experiment, you can change the name. And then finally, you can add any relevant configs here that you want to make sure to keep track of later. So I really encourage you to, when you're log more than you think you need to the config, because you never know after a few days of a week of doing experiments, actually what was that setting that you actually turned out to make a big difference. And so it's always better to be safe than sorry and log as much as you can to your config, so that you have the full picture of how you trained the model in a few days or a few weeks. And so in this case, we've started the weights and biases run. It's running. This is just a simple dummy example of some of the in a training loop, some of the metrics we might be logging. And so here we're just calculating a kind of random but ascending accuracy and a loss that's slowly descending. And then once you have those metrics, like I said, you saw before with the table, you just call 1db.log. And so here you pass your metrics in as a dictionary, and this accepts ints or scalars or floats. Not fussy on the data type here. And so this is just simulating a training run once you're finished your run, like I saw before, you just call 1db.finish, and that'll be your metrics logged to weights and biases. Here, we have an actual like bit more of a real example, and so here, we're actually doing a small experiment on a real, mini model, and varying a parameter which is called dropout. And so dropout in machine learning is especially in neural networks, is when you deliberately randomly set some of the weights in your model to 0, and it's useful to regularize your model, or in other words, it prevents it from just memorizing your training data, but instead helps it learn general concepts. And so here, this is just a quick experiment where we're setting a random value for our dropout, which is then being passed to our model in the step here. And then we're looking at the impact of how that random change impacts your metrics here. In this case, our training loss, and later on our validation loss here. And so here is another example of logging to a weights and biases run. So this is like the kind of 101 of logging to weights and biases, and this runs nicely in a REPL. For something more advanced, we also have this example. So here we're training a vision model with Hugging Face transformers, which is a popular machine learning library, both for text and image training. And so here you can take, if I reload this, you can take a browse through the code here. In this case, we're actually using a inbuilt integration that we have in Hugging Face transformers in their trainer. And so here, there's actually less weights and biases code that you need to run, which is cool. You can simply set a parameter in the trainer, and then that'll automatically kick off weights and biases logging, and start training your vision model, and sending metrics back to weights and biases. And so you can take a browse through the code here. I'll just get down to where you're setting weights and biases. And so here, Hugging Face's trainer takes these training arguments. And so this is how you turn on weights and biases logging. You just simply set report to 1db, and then you're good to go. You can see those training arguments being passed here to the trainer. But once this trainer gets instantiated and report to 1db is running, you'll be then prompted for your API key, unless it's already in your secrets, and then your model will start training and your metrics start get pushed to weights and biases. The last example I wanted to quickly run through was this example of Nano GPT. So I think probably most, if not everyone on this call, has heard of Chat GPT at this point, and also GPT-3, these super powerful models from OpenAI. And so Andrew Karpathy, well-known machine learning professor at Stanford, and also the ex-head of autonomy at Tesla, has this wonderful little library called Nano GPT. And so this is an example of this library, or this model being trained in Replit. And so he's written this, he's really boiled down the training code and the model code to train one of these GPT models to its bare bones. And so if you're interested in how all these crazy big models are trained, this is a really good place to start. He also has an accompanying couple of YouTube videos that we can put into the resources we'll be sending folks as well. And again, he actually just started using weights and biases for this project, which was a pretty cool thing to see. And so this is a slightly modified version of one of his scripts. And yeah, I don't need to run through this code. We don't need to watch this REPL load on my slow internet right now. But yeah, that's more or less, I think, everything I wanted to run you through today. Like Ornella said, we'll be in the Replit Discord in the Machine Learning Hackathon channel all week. Myself, Corey, the ML engineers in my team, are there to give you a hand, make sure you're getting set up, make sure all your weights and biases login is running well, answer any of your machine learning questions. And yeah, happy to pass it back to Ornella.
Hello. Thanks, Morgan. That was amazing. I feel like I learned so much just watching that. Also, now I really want a torta. Thanks for that. But yeah, I just wanted to pop back in to explain the submission rules and walk through the prizes again, because we know that's why you're all here. So let's do that quickly. So this is the Hackathon website that I'm sure many of you have seen already. And it's also where you can still apply to participate in the hackathon. Like we said, you can apply until Wednesday and we'll accept new people every day. So it's not too late. Wanted to go over the rules once again. So the main thing is that you have to have both a Replit account and a weights and biases account, and you have to use both technologies in your project. So that's going to be the really important thing. And the last date for valid entries is 11:59 p.m. next Saturday. And this is Pacific time, so just be mindful of that. The form will not accept submissions after that point. And the actual submission form will be sent to your emails also this Wednesday. So stay tuned for that. If you're really, really fast and you finish your project before then, that's awesome. Make sure you submit it on Wednesday, but we think, it might take people a little bit of time to get going. So the next thing that I wanted to talk about is teams briefly. So it's totally okay to participate in a team, and you can just let us know who's a part of your team when you submit your project. But the important thing to consider is that you're going to want to make sure that this for the submission is the same Replit account that was accepted to the hackathon and also is the one that got the cycles for GPUs. So we won't be granting cycles to everyone in your team. It'll just be the account that was accepted to the hackathon and receive that email. And the prizes, to go over one more time. So like I mentioned earlier, everyone is eligible for the grand prize as well as the honorable mention. And then on the submission form, you will choose whether you want to be eligible for the best weights and biases report or the best Replit project. So the grand prize, 300,000 cycles, which is amazing. Think about all of the community REPLs you can tip with that, or all the bounties you can post with that. We've got 100,000 cycles for best weights and biases report, as well as best Replit project. And then for honorable mention, 50,000 cycles. Also for best Replit project, make sure you share your work to community using the WANB tag so that we can see all of your wonderful projects. And Morgan and his team at Weights and Biases will choose the winners. So those are the folks that you want to impress with all of your projects. And yeah, just wanted to say a really big thank you to our guests. I'll pull you all back in really briefly. Thanks so much for being here on a Saturday. We really appreciate your time, and we'll see everyone at the closing ceremony on the 15th.
Brilliant. Yeah, and looking forward to chatting with everyone during the week in the Discord as well. I think we'll try maybe have some daily updates and showcase any early cool projects. We also actually have one cool example coming maybe on Monday where you've probably seen examples online where people are trying to replicate ChatGPT, using the open AI and using external knowledge bases. And so we have a cool example like that coming, which I think works really nicely in Replit and Weights and Biases too. So yeah, looking forward to hanging out with everyone for a week.
We have one question in the chat. How many people can there be in a group? I would say that, Morgan, I defer to you on that.
Yeah, no strong opinion there. Machine learning projects tend to be tricky to manage when you've got more than 2 to 3 people, I think. But yeah, I guess there's no hard limit on the amount of people in your team. Bear in mind, I think it's only going to be one account that the cycles are going to be credited to if you do win, correct?
Yeah. So just be mindful of that and do whatever you wish within those bounds, I guess. Amazing. If anyone has any other questions throughout the week or today, please post in the Discord channel and we'll get back to you. But otherwise, look for communications from us via email and also in the announcements in the Discord channel. Thanks so much for joining us today.
Brilliant.
We'll
Thanks,
see
everyone.
you
See you.
soon. Bye.